Well, we're gonna break things because that's fun. So I gave this a name. I'm calling them capsule images. Kind of like medicine. You take medicine the wrong way, it can hurt you. So you should know what you're doing. But this is a common question that's asked is there a way to get Yocto to build an image that only includes what I want and nothing of what I don't want? So don't follow the dependency tree. Don't pull in things that I don't ask for. I really want to be specific, and I understand that I break it, I bought it. This is risky territory I'm in, right? So this is an example of one of the questions asked. I responded to this a while back, but didn't do much with it at the time. But now I'm doing a presentation, and we'll see where things go. There's some pros and cons to this, obviously. It allows you to maintain a pristine production image and sort of carry around portable debug tools. Like you can drop in an SSH layer or drop in symbols with GDB and all those kinds of things, so that you don't actually have to modify the build at all. Obviously, the cons are you break it, you bought it. It breaks very easily. So normally, in my experience, it's best to include these types of image generation with your nightly build, so that the toolkit always maintains some degree of parity with your build image. But it can still break when overlaid. It may be missing things it needs. So you have to be careful with this. And then it obviously violates a lot of image generation assumptions. Yocto is really good about taking care of a lot of externalities for you. This basically breaks all of them. So for runtime, I found that it works best with overlay FS. So you're mounting your layer along with the root FS mount. So obviously there's a whole set of things you have to do to make sure that occurs. In the past, I have written my own initram FS init script, and it's just a bash script. So it'll gather up all the overlays, neatly stack them, and then do the switch root and just call systemd as part of the main init. And this would be part of it. It's sort of an optional thing you would probably load maybe by serial interface or whatever, reboot, and you're good to go. The root FS is expected to fulfill the missing dependencies like glibc, all those sorts of things. And then you will need probably a capsule image startup service, something that, you've got where, all the layers load in sort of a lexicographical order. And then there's a integrate script, which I'll talk about here in a minute, that would effectively run all the post install that would have normally run during your image generation. So you're on, and that happens, obviously you'd have to make sure your overlay FS has a read-write layer on top of it. Otherwise that's going to fail. So there's a fair number of dependencies that have to occur here. And then you can have shadowing. So you got to make sure that your capsule image doesn't shadow things you don't want. So we'll go into some of that. And then, so here's what a recipe looks like. It's pretty simple. You can do it with 15 lines of code, even less, depending on the packages you want. This is for an SSH capsule layer. And then obviously you can set your priority. You'll probably note that 90 does not show up as 99 here. So that was just probably something I have to look into in the BB class. The BB class itself, I put it up on a gist for now. You can take a look at it. But really it just consists of disabling a lot of stuff, ignoring some stuff. And then the hardest part is all of the post-install scripts for your package dependencies. You have to sort of concatenate those in an intelligent way into the integrate script that's called by your mechanism inside your as you're booting. You have to disable the set-e behavior because you want this to be best effort. You don't want it to fail at the slightest hint of failure, which has its own problems. All those scripts are generated assuming they're going to fail fast. So be prepared. And then, of course, core image has its own post install. You want to remove that as well. And then you need to delete files, manually delete files that shadow the production root FS files that you don't want, like etc password and those sorts of things. I'll go over to the BB class to give you an idea what it looks like if you haven't pulled it up already yourself. A lot of these things are just neutering current behavior. You do need to pull in some things to extract packages. I'm using OPKG, IPKs. You can do this just as easily with RPMs. Disable behavior. You don't need a init. And then this is the integrate script you create. This is sort of the majority of the behaviors. You got to go extract all the from the control scripts, all of the control and pre and post install stuff, and just concatenate it to your integration script. Disable your set-e, remove stuff you don't need, and off you go. And then post process, remove your shadow. Anything that shadows that you don't want, remove that, so that you've got at the end a cleanish result. So this is a bit of an eye chart, but it fit in one screen, the resulting image, and you'll see that it's got all of what you need and none of what you don't, but maybe it's got a few things you don't want in there. Okay, so you build it, you go to your deploy directory, you mount it, and then you look into it, and that's sort of the lather, rinse, repeat, debug process to get your image situated. And so you can go in and figure out if something's left over. I had decomposed it. I wanted to keep so I'll go back to the recipe slide here. I had decomposed it. I wanted this recipe to be really, really simple. I didn't want any extra logic, but it's entirely possible that, we'll go back to the BB class. It's entirely possible that maybe shadowing behavior, you want to customize that for your recipe. So it's debatable if you want to include cleanups in the BB class itself, or go back to the recipe, or you want to have that behavior specified in the image creation. I found that the vast majority of the time you don't want to shadow certain files, so that you can just, I'm gonna go back here, you can just assume you can remove those. So this breaks a lot. I'm sure Richard's going to be horrified by something like this, but it's super useful. It allows you to create a nice handy toolkit to carry around with images. Include this in your nightly build. I'll go back here. Include it in your nightly build, so you always have a toolkit that's current. And in fact, you can actually pretty easily in your build test environment overlay this and do some cursory tests to make sure that in this case you can SSH in or whatever, and you haven't broken anything, overshadowed something you don't want. So it's fairly easily testable once you get your arms around it. And this one ended up being about 72 lines long, just for SSH functionality, and it does work great. I use this all the time. Like I said, you can do this GDB, symbols, keep your production image clean and overlay. Otherwise, pretty happy with it. And I think we have time for questions. Let me check the chat here. Oh, good. Yeah, thanks for posting the gist. Let's see. So what is the advantages compared to containers? I really, I'm gonna be honest, I really don't like containers. I think they're floating islands of misdirection that can, create confusion. And besides, to some degree, overlaying stuff like this does exercise your core image. And then if you're trying to debug your core image, you can't put your symbols in a container. You have to overlay on top of your running image to really be able to debug the binaries you have running at the same time. So for a lot of reasons, it just makes a lot of sense to overlay. Oh, and by floating islands of misdirection, I did not create that. I stole that from someone else who stole it from someone else. So probably Abraham Lincoln came up with it 200 years ago. So I'll try and I'll probably bring this up in one of the tech meetings to see if now that I've sort of revealed this, if there's any interest in adding it to OE or somewhere else, or if maybe this is just so abhorrent it needs to live on its own. But I think it's very useful. Is it easy to brick everyone with this? Yes, of course, obviously. For an embedded device that requires, like, if you have to use a RS-232 loader or something, you could do something wrong where you boot and wedge yourself into a condition where, you can't delete your overlay now, and you just go into boot loops. So you have to be careful. This is not something that you should not tread lightly doing this. Would you use it with anything prod instead of dev tools? I mean, it's just how you look at it. So there's a lot of good reasons to use overlay FS, even as a production image. For example, if you want to create a base platform and then you want third parties to create overlays. So you want to create distributed development environment. So you want, and you're not pushing them off to their own cheroot, for example. You actually want your third parties to create core functionality, but you don't want to involve them in your base platform development. Overlay FS is a really great way of doing that. They can just drop in what they need and plow forward, and then you can sort of collect that and sandwich yourself together a runtime image. So it is useful in that way. Let's see, what are the typical space savings? I mean, this is 72 lines, so do the math. You start throwing in everything that it needs. So again, so you want to ask why, it'd be better than a container, right? Well, a container has to come with everything, right? And just imagine all the things you have to include in there, which is by definition going to be a lot more, because you can take advantage of what's delivered with the root FS. Let's see. Yeah, I don't know. I haven't used systemd sysext, so maybe I'm totally recreating the wheel, and we can all have a good laugh about it. Yeah, it is complex. Although once it's working, it doesn't seem to be something that hasn't required a lot of maintenance, and it has provided a lot of useful, helpful things. And it's also, if your loading scheme is pretty well understood, however you load stuff into images, it's a really useful tool for even users that you just don't need to train how to be technical about creating embedded platforms. Not everybody needs to know how Yocto works, and this is a good way of handing them a thing and saying, here's your tools. Let me know, particularly if you're your test team, is tasked with breaking things. Any more questions? We got like a minute left, I think. So I'll bring it up, I think probably on IRC or something, or maybe a tech meeting, and see what the general interest is, and then we'll see if maybe shaping it up and cleaning it up and whatever, and where we want to go with it.
Thank you very much for this wonderful talk and the amazing background. Welcome to the real world.
Thanks.